Hello, this is Stefan again. Today I would like to talk about a really new feature in our HVAC lib, and that is called the pressure mode. So in the previous versions of HVAC lib, you were used to design your systems following the performance-oriented approach, which means that you had to take care of proper distribution of the mass flow. So each split of your system, you had to define a split ratio, and that could be either fixed or time dependent, as in this case. So let us assume this use case. We are starting with equal distribution of the mass flows, and after 10 seconds we have a ramp up to 1/3, leaving the second outlet of the split, and 2/3 will leave to the first exit. Now we have created a new calculation mode, and that is called the pressure mode. How to use this pressure mode for a detailed hydronic balancing of the mass flows. First of all, there is a global parameterization model that is called globals. And in the new version of HVAC lib, you find under settings a deactivate pressure calculation flag. And this can be switched from true. True is the general setting, the default setting. And you can switch it now to false. And after that, you see here a P character that indicates that this setting has been deployed to all the components part of your system. So what does it mean? So first of all, when we look at the pump, then this affects the calculation of mass flow and pressure head. So since we have used the pump model in the non-pressure approach before, we now have to switch to the pressure approach, the corresponding pressure approach, which is here the volume flow rate model. This is necessary because the equation system and the total system has changed, and in order to obtain a balanced mathematical equation system, we need to switch to this setting. Furthermore, since we are now able to calculate the mass flow depending on pressure losses, it might be interesting and relevant to switch all the pipe models to the detailed pressure drop model. What is this good for? This is especially interesting because you might wish to change the geometry of the pipes. This means in terms of the length of the pipe or in terms of the diameter of the pipe. And all these parameters will affect the pressure drop of the pipe model, and also the mass flow that can be obtained and achieved through the pump in the overall system. When we continue to look at the split model, we see that one of the inputs has actually vanished. And the reason is that in the new calculation mode and the pressure mode, the distribution of the mass flows is actually calculated from the pressure differences over the attached branches. So this means if we increase the length of one pipe or we decrease one diameter of one pipe, this will decrease the mass flow through the corresponding branch. Furthermore, in this mode, we have the option to include two-way valves, which are new models in our HVAC Lib 3.4. And these valve models can actually control the mass flow through each branch. Here we see the model of the pressure approach with the two-way valves included. And these valves can either be used with a fixed opening value, or they can be attached to some signal source that provides an input to the opening of the corresponding valve. So here, in this case, we attached one ramp model to the first branch, and this ramp model that will actually increase the mass flow through the first branch after a time period of 10 seconds. So let us compare the results. I will simulate this model for 15 seconds. And as we can see, the simulation is fairly fast. And this is one beauty of our concept. We don't need to care too much about the initialization of the system. So I have not really provided any initialization, specific initialization parameters to the system. And it will start really fairly robust. All right, so let us check the mass flow through the pipe 1. And we will see it has changed as intended. So after 10 seconds, it will increase to 0.66 kilogram per second. Before it was 500 gram per second. So yeah, it increased to 2/3 of the total flow. So let us return for comparison reason to the model with the performance-oriented approach, which is shown here. We will simulate the system for the same time period. And afterwards, we will compare with the previous result, the pressure approach, and we will see that the results are fairly matching, very good. we have to take into account that the parameterization is a bit different. In the pressure mode simulation, of course, we have been using the two-way valves for influencing the mass flow through the corresponding branches. But yeah, in fact, both systems are fairly well matching. And yeah, the good news is with the HVAC lib now, you are able to simulate the hydraulic balancing of a heating system or liquid system, which is a big achievement in my eyes. So enjoy using the new pressure mode.